Hi everyone. In this video, I'm going to discuss HDLC frame for bit stuffing and character stuffing. First, we need to know what is HDLC. HDLC is nothing but a protocol where HDLC stands for High Level Data Link Control. As you know that by the name only, data link control, where it comes, this data link control, it comes under data link layer. So what we'll see means first, we'll see HDLC frame format. The frame format mean to say that HDLC is a protocol and it has its own frame format. Okay, it has its own frame format. So before that, we need to see what do you mean by frame. Okay, so the frame actually it comes under your data link layer, which is nothing but data link control. As I told you, data link layer is divided into data link control and medium access control. So we are discussing data link control. In data link control, we have a characteristics called as framing. So what is framing? Framing is nothing but your stream of bits, okay, coming from the upper layer. Stream of bits coming from the upper layer is divided into smaller units called as framing. Okay, there are two types of framing. One is called as fixed size framing and variable size framing. What is fixed size framing? It is nothing but like the boundary is fixed here, okay, where the size is fixed here. Whereas variable size framing, the boundary is not fixed and the size is also not fixed. For example, if I have a frame which has the capacity of 8-bit means it can store only 8-bit. If I have a frame of 16-bit means it has the capacity of only storing 16-bit. Okay, whereas variable size framing, there is no restriction in the size, okay, fixing the size. So any number of bits can be added into the frame. Okay, that is variable. So because of the complexity of your coming applications, so we need to go with variable size framing. So whatever we'll discuss now is a variable size framing here. Okay, so before going into that variable size framing, first we need to know what is the exact format, that is HDLC frame format. Okay, that we'll see. Okay, for that one. Okay, so we can see here. Okay, so HDLC frame format consists of how many fields? Total 6 fields. It starts with the flag and it ends with the flag. Remaining, it has address field, control field, information, and FCS. Now we need to know what is why this flag field is present. So as you know that we are discussing variable size framing where the size is not fixed. Okay, whereas in the fixed size framing, the size is fixed. So we know which is the starting of the frame and which is the ending of the frame. Whereas in variable size framing, we are not able to distinguish which is the start of the frame and end of the frame. So that's why for that purpose, we require so that can be overcome by using a flag at the beginning of the frame as well as at the end of the frame. And this will have its own flag pattern. Okay, if it is a bit means if the information is in terms of bits means, so the flag pattern will be in terms of bits. If the information is in terms of character means the flag pattern will be in terms of characters. Here the example shown here is the information is in terms of bits. So the flag pattern is followed by 6 ones and 0. And it is of how much bit? 8-bit sequence it is. And it is present at the beginning of the frame and end of the frame. Okay, so now you know why flag is required in variable size framing. Similarly, this is nothing but address, source address, and destination address, which can be 1 byte or several byte. Next, this is the control field, which is of 1 or 2 byte, and it is for flow control and error control. Error control is nothing but for error detecting and correcting, and flow control is nothing but sender rate and data rate both should be same. Then only packet will not be lost. Otherwise, if sender rate and data rates are different, definitely there will be loss in the packets. Okay, that is control field. Next, coming to your information. Information is actual data. Okay, that is varying. Okay, you can see that the length can vary here. And next, FCS. FCS is frame checksum, which is used for mainly for the purpose of error checking. Okay, so this is about the HDLC frame format, which is important. Okay, so next, now what we'll do means we'll actually enter into the concept called as bit stuffing and character stuffing. So for that, what we'll do means first we'll see go with bit stuffing, and we need to know why we are going with bit stuffing, or it is also called as bit oriented protocol. Why bit stuffing is, so as you know that this is the frame. Okay, this is actually the frame. Okay, which consists of start flag, end flag, header, that is address, and tailor, that is FCS. Okay, and this is the actual information which is coming from the upper layer, which is of variable number of bits. Okay, since it is a variable size framing. Okay, now why bit stuffing? Now you know that the flag pattern is fixed. What is the flag pattern fixed? It is 0 followed by 6 ones and 0. Here also 0 followed by 6 ones and 0. Suppose if this is present here, okay, suppose if this is present here, okay, like for example, if I show you here, okay, if the data, okay, uh, sender data is how much? 1 0 1 1 1 0 1 1. Okay, this is the data that is present at the sender, which you got from the upper layer. Okay, which you got it from the upper layer. Okay, I'll place it here, or I'll place it here only. Okay, no issues, I'll place it here. Now what happens? Okay, now sender, where it has to send? It has to send to the receiver. Okay, it has to send to the receiver. Now what receiver will do? Receiver will start receiving one bit after another bit. So first it will receive this one. Okay, so it takes that one. Then what happens? 0 will be received. It takes that. Again 1 it will take, 1 it will take, 1 it will take, 1 it will take. Then 1 it will take, then 0 it will take. Now receiver recognizes. Okay, now receiver recognizes this thing. Okay, this thing as what? It will recognize as the flag. It will recognize as flag. Now what is the remaining data it will receive? The remaining data it will receive is 1 1. Okay, now what is the actual data? Now receiver has recognized this 0 followed by 6 ones as the flag. Now the actual data you are received. Okay, actual data received is how much? 1 1 1. Okay, what is your actual data you are received? But your original data is this one, but the data you are received is this one. So what happens? Whether you received the correct data? No, the information got lost because of the presence of flag. So to overcome this problem only, we are going with bit stuffing. Okay, so okay, so next what you'll do means, how the bit stuffing is done, we'll see. So what is bit stuffing? Bit stuffing is nothing but adding one extra 0. When you have 0 followed by 5 ones. Okay, so bit stuffing is nothing but adding an extra 0 when you have a 0 followed by how much? 5 consecutive ones. Okay, so that receiver doesn't mistake the pattern as flag pattern. Okay, now see, this is your actual data. Okay, so this is actual data. Now stuffing is done here. So how the stuffing is done? The stuffing is done in this way. Whenever 0 followed by 5 ones. Okay, whenever you have a 0 followed by 5 ones, it is stuffed with 0. Okay, similarly, wherever you find 0 followed by 5 ones, it is stuffed with 0. Okay, it is stuffed with 0. Okay, so this is what the stuffing. Okay, so how stuffing is done? Whenever in the data, if you have a 0 followed by 5 ones, irrespective of the next bit is 0 or 1. Okay, irrespective of the next bit is 0 or 1. So if I want to show it here, whenever you find 0 followed by 5 ones, okay, immediately you stuff it with 0 irrespective of next bit 0/1. Okay, that is what you need to know here. This is called a stuffing that happens at the sender side. Okay, coming to the receiver side, it will do it in the other way. Other means when the receiver identifies, okay, a 0 followed by 5 ones, the next bit, okay, the next bit, whatever, this is the next bit, is not considered. Similarly, whenever 0 followed by 5 ones, the next bit is not considered. So your original data, you got it. Okay, so your actual data, you got it. So this is nothing but bit stuffing and unstuffing. But in your program, we are doing only this bit stuffing. Okay, so I'll clear this one. Okay, now we'll go enter into the program. Okay, now we'll start entering into the program. Okay. Okay, so this is the program. Okay, fine. We'll start with the program here. Okay, so we'll see the program here. So they will start with the first line. The first line, you know that it defines stdio.h, and the second line defines stdlib.h. Okay, so now we'll enter into the main function. Now consider ch as a character, okay, for the data, for each and every bit, okay, to declare. Next, what you'll do means, next we'll consider a variable of array 20. Variable of an array 20 it is. Next we'll consider a count. Why this count is required? In order to count the number of ones. Means, as you know that if you have a 0 followed by 5 ones, okay, followed by 5 ones, what happens? The next bit should be stuffed with 0, irrespective of the next bit 1 or 0. This is the condition. So this is what we are doing here. So to count this 5 ones, 1, 2, 3, 4, 5. After 5 ones, you should stuff with this 0 here. So that's why this count is required. So, and this I is equal to 1. Okay, this I is equal to 1 in order to read. Okay, in order to read each and every, in order to this I is equal to 0 is in order to read each and every bit position. Okay, each and every bit position, if you want to read it, this I is taken. Okay, next j. This j is for the purpose after stuffing. So you are stuffed here. So after stuffing, you need to what? Read the data. Okay, reach each and every bit. For that purpose, j is taken. Okay, now start entering the data. So we'll enter the data here. So now the data is 1, 0, 1, 1, 1, 1, 4, 1, 0. Okay, so we'll take a small data here. Okay, this is your data here. Next, what happens here? Now get ch. What do you mean by get ch? Get ch is nothing but a character. It is nothing but a getting a character, and getting a character when you enter. Like for example, when you enter on the keyboard, okay, it takes that character. Okay, it takes that character and echoes. Okay, echoes means it displays on the screen. That is the meaning of this get che. E stands for echo. Okay, so in simple words, if I want to tell, suppose if you're typing something, you're typed what? 1, 0, 5 ones and 0, you're typed. So that will be taken. That is taken care by get ch. Okay, now once it takes, it will display on the screen, or it echoes. Okay, or it echoes. That's why E is echo, displaying on the screen. Whatever you type on the keyboard, it will be displayed on the screen. Okay, now this each and every bit will be taken. Okay, each and every bit will be taken here, taken care by get ch, and each and every bit will be considered in ch. Okay, it will be considered in ch. Now this, what is this slash r? Okay, slash r. So slash r, what it does? Okay, slash r, what it does means it. Okay, now what this slash r does? Okay, slash r, what it does means it is called as carriage return. Okay, so what carriage return will do means it helps to move the cursor at the beginning of the line. Okay, it helps to move the cursor at the beginning of the line. So what is this? Is not equal to. Not equal to means, so what happens here when this condition satisfies? So it is nothing but it will take each and every bit and it will be considered in ch, and also it checks that whether all the bits are considered. Once it comes at the beginning of the line, okay, once it comes at the beginning of the line, then what happens, the condition will not satisfy, it will come out of this while statement. So that's why here not equal to, not equal to means it is not at the beginning of the any of the line, so some data is considered here. Okay, each and every bit is considered here. So how much ever bits you have typed, so every bits are considered. One first one will consider, then zero will be considered, then one, then one, then one, then one, then one, then zero, it will be considered. So not equal to means these values are considered. Equal to means it has returned to the first line. Okay, it has returned to the beginning of the first line. So what happens, no data is present here, meaning, okay, so then it will come out. So no data is there, then it will come out of this loop. Now it will start considering here. So now what we'll do means we'll start considering the first data. So what is the data? I can write it here is 10340. This is the data I'm considering it. Okay, so see here there are 3 4 5 and afterwards I 0. So after 5 ones it can be either 0 or 1. Okay, now what happens, first this data, if I want to make it clear, I'll clear this one and write it properly. So 1 0 1 1 1 1 0. Okay, so this is what the enter the data. Now get ch will consider each and every bit and consider it as ch. It will be considered in ch, and see to that it is the cursor is not, it helps the it sees that the cursor is not at the beginning of the line. Okay, if it is at the beginning of the line, then it says that there is no data present here. Now there is a data present here because the first value will be considered here, which is that this one will be considered. So now it will enter into the while loop. Now what happens here? Now you can see here ch is equal to 1. Yes, ch is equal to 1. So because first bit is considered here. Okay, if I show you here, so this is considered first. So ch is equal to 1 here. Now what about the count? Count initially it is 0 here. Now what the count will become here? The count will become, okay, count is equal to 1 here. Correct. So now what happens, else statement will not do. Okay, else statement will not work here because already this statement is satisfied. Now what happens, what about this one? This one, now a, what is I is equal to 0. I plus plus means a of 1. A of 1 will be stored with a value, which one? Ch. What is ch? Ch is equal to what? Presently it is 1 now. Okay, now next it will check whether count is equal to 5. What is count value now? Count is equal to, actually the count is what? 1 it is. It is not equal to, okay, it is not equal to 5 it is. So what happens here? So this will not satisfy and this statement will not satisfy here. Okay, now further moving, what happens here? So where it is at this point. Okay, so at this point, so this statement will not execute. Okay, again what happens, the next, again from here, again it will go to the while statement. So what is the data we are considered? The data we are considered here, so sorry, the data is this one. Again I repeating. Okay, this one. So at present this is done. Okay, this is done. Now what is the next one? Okay, next it will read this one. Okay, so it will read this one. Now at present, what is this? Ch equal to 0. Now when Ch is equal to 0, what happens? This will not be done. Count will become 0 and this one. Okay, so this one is what? A of Previously a was 1, now a will become 2. A of 2 is equal to what? 0. That is equal to ch, correct? Okay, now what happens? Count is equal to 0. Okay, count is equal to 0. So what happens here? This will count is equal to 5. So it doesn't satisfy this condition. Again, it will go back to the while loop. Now 0 is finished, then 1. Okay, now at present what happens means, now this one, instead of ch is equal to 0, now ch is equal to 1. Okay, similarly, what happens here? Okay, ch is equal to 1, then this will execute. Okay, which one will execute? This, since ch is equal to 1. Okay, now count will start incrementing. So what is the count? Previous count was, it was 0. Now count will become how much? 1 year. Okay, count is 1. Now what happened? Next is this count will not become 0, and this one. Okay, now a of 3. Okay, a of 3 is equal to how much? Ch is nothing but 1. Okay, now it is reading. Okay, now what happens? Again, count is not equal to 5. What is count value? Count value is equal to 1. If I write here, so count is equal to 1 here. So what happens? This condition will not satisfy. Again, it will go back here. Now what it will do? Now this is completed. Which is complete? This is completed. Okay, till here we have finished. Okay, next this will be taken. So again, this will be 1. And what become? What this will become? This will become, now the count will become, previously it was 1, now the count will become 2. Okay, now this one will be a of 4. Okay, so a of 4 is equal to 1 year, correct? Next, what is the count here? The count is equal to, okay, count is equal to 2. Okay, count is equal to 2 year. Okay, this is so. So what happens? Again, it will go back. Now what happens? This is completed. Okay, similarly, like that, if one more 1 it is identified, here the count becomes 3. Okay, this becomes 3. Okay, and here this become 5. Okay, and this become 3. Correct? Okay, so this is covered. Next, same position. Next, this will be done. So that time what becomes? Count becomes 4. Okay, and this one is, this will be nothing but a of 6 is equal to 1. Correct? Again, this will become what? 4. Okay, next, this is over. The next one, it will read this one, and it will read this one, ch is equal to 1, and this will become 5. And here you can write it as a of 7 is equal to 1. And next, this becomes 5 here. Okay, now the process start. Now what happens here? Okay, now this condition is satisfied. Okay, this condition is satisfied. Now it will enter into this one. Now what happens here? Now what is I is 7 here. Now what it will enter? A of, okay, 8 is equal to stuff with 0. Now you make your count initialize to 0. Okay, now again it will go back here. Now what happened to the count? The count has become 0. Okay, count has become 0. Now a of this is over. No, this part, see here, after this a of 7, it is a of 8. Now what happens? Next one, A of 9. Okay, A of 9. Now what is this one? Before that it is reading which one? This is also red. Okay, if I want to say here, this is also red. Now at present it is reading which one? 0. Present it is reading 0. So what happens? This will not be satisfied. Okay, this will not be satisfied. So this will be satisfied. Okay, after count 5, after this count 5, next it will read this 0. When it reads this 0, it doesn't satisfy 1. So count is, it will not increment the count. So it will be 0 here. So it will read 0. Okay, count becomes 0. Okay, and now A of 7. Okay, A of 7, A of 8 is over. So next it will be A of 9. Okay, A of 9 will be 0. Okay, now this is also red. Okay, this is also red. Again, this count is equal to 1 will not satisfy. Now all the character has been read. Okay, all the bits has been read. Now it will come out of this this loop, that is while loop. Now it will say the stuffed data. What is the stuffed data? The stuffed data is, I'll write here. So what is the stuffed data? That is present here, 1 0 1 1 1 1 1. Now 0 1. This is the stuffed data. Okay, stuffed data, and where you are inserting your bit stuffing, that's why the bit stuffing you are inserting with 0 here, that's why bit stuffing here. Okay, so now what happens? Once it is stuffed, now each and every bit has to be read. Okay, each and every bit has to be read here. So how this is, each and every bit is read here, so that is taken by a variable j. Okay, that is taken by a variable j. Compare with I, because a of I, a of 1, a of 2, a of 3, it is stuffed data. Now comparing with your j. Okay, so that will be printed. So here it will be printed, it as same, the stuffed data will be printed here. Okay, so this is about your logic of your program. So next what we'll see means the execution of the program here. So next we'll see the execution of your bit stuffing program using, that is C program. Okay, for that, okay, open the code blocks. Okay, then file, new, project, console application, go, next, C, next, and this is nothing but your bit stuffing. So bit stuffing, new. Okay, so give next, then click on this plus, double click on this one. Okay, now what we can do means we can copy that program. Okay, same thing what I explained, the same program it is. So copy and paste it here. Okay, then save this one. Okay, then build this, then run this. So enter the data. So what data we gave? 1 0 1 1. So I'll maximize this. So 1 1 1 0 we gave. Okay, this is the data we gave. Now we'll see what is the stuffed data. So you can see here the stuffed data is, so if I show with this, so see here 1 0 1 1 1 1 1, and the stuffed data is this one. Okay, this is your, this one. Okay, this is your stuffed data. Okay, how much single bit is stuffed? Okay, single bit is stuffed data, single bit, that's why bit stuffing it is. So if I want to make with another example, okay, so clear this. Okay, go with another example. So 1 0, I can write here this one. So enter here. So we'll see where the stuff data is. 0 followed by 5 ones. Here we have stuffed here. Then 3 4 5. Again see here 0. Okay, again wherever it finds 5 ones, again it will start stuffing here. Okay, and again remaining data here. Okay, this all the stuff to data 0, and here stuff wherever it finds 5 ones. Okay, it will stuff with 0. The next bit will be stuffed with 0. Okay, so this is the output of your bit stuffing. So in the next video I'll continue with character stuffing. Okay, thank you.